Hello class, welcome back to our final section on limits of functions. In this video, we are going to tackle limits of transcendental functions as well as the Sandwich Theorem, and we will solve some examples. If this is your first time visiting this class, kindly press the subscribe button and don't forget to like the video. Limits of transcendental functions. In our functions video, we learned that transcendental functions are functions which are not algebraic. To get more insights, kindly subscribe and get access to the videos. So when you want to find limits of transcendental functions involves Euler's number and exponential functions a lot. So here are some basic limit properties relating to transcendental function, and it says limits of e exponent x as it approaches negative infinity is equal to 0. Why? Let's see something here. If I have limits of e exponent x as x approaches negative infinity, I'm going to get e to the power negative infinity, and this is going to give me 1 over e to the power infinity, which is 1 over infinity, and any number over infinity from the determinate forms will give me 0. Hence it is being proved. The second is limit as e to the power x as it approaches positive infinity. That one is positive infinity, yes. Or e to the power infinity will give us positive infinity. Then the third one is limit as we have e to the power x over x to the power n. See this one. Limits as e to the power x over x to the power n as x approaches positive infinity is equal to positive infinity. Why? Why is this not indeterminate form? If I put infinity here, I'm going to get what? Infinity. And if I put infinity down here, any number n will give me infinity, but it's not going to give me indeterminate form. This is because when you have x as the power here, so a number raised to the power infinity will be so huge, so the infinity I'll get at the numerator will be very huge. But when I get this number here, down here, then if n can be any number which is natural number, so it is assumed that the positive infinity I'll get here is far smaller than this. Therefore, you get positive infinity as a resulting solution, and this will not give us indeterminate form. Then we move to the natural log. So he's saying that the limits as ln x approach s, the limit of ln x as it approaches 0 from the right side will give us negative infinity. So if you have 0 from the right side, then we're going to get negative infinity. That is, when they give you length of 0.04, length of 0.05, our resulting solution will give us negative numbers. Then let's see the last one. Limit as ln x, limit of ln x as x approaches positive infinity is positive infinity. Yes. On this note, let's solve some few examples here. So the first example is limits of e to the power negative x to the power 4 plus 3x squared minus x as x approaches negative infinity. So here you know that wherever you see this x, you put negative infinity there, and I'm going to get e to the power negative of negative infinity all to the power 4 plus 3 negative infinity squared minus negative infinity, so minus negative infinity. So you remember that in some of our videos, or in our previous video, we got this indeterminate form. This is going to give us negative infinity, then this will be positive, then this one will be positive plus positive infinity, and this is indeterminate. Negative and positive is indeterminate. So what you do is we are going to factorize this out. So we get e to the power x to the power 4 negative 1 plus 3 over x squared, then minus 1 over x cubed. I factorize this out. and at that point this term will be 0, because when I put infinity there it will be 0. So my final function will be e to the power negative s to the power 4, and when I put my negative infinity there, negative infinity to the power 4, I'm going to get positive here, and my solution will be e to the power positive infinity, and hence, this will give me a positive infinity, the one in the bracket, so it will be negative infinity rather. Then at this point I'll get 1 over e to the power infinity, which will give me 0, as simple like that. Now let's take the second example. The second example involves, example 2 involves limits as lim x plus 1 over x as x approaches 0 plus. Now let's see this one. If I put the 0 right here, I'll get undefined, yes. If I put 0 here, I'll get undefined. Even putting the 0 here will also give me undefined. So what do? We are going to get lim of x plus 1 multiplying 1 over x like this. You separate it. When you separate this into two multiplying functions, then we come back to this property. It's a limit of any rash n. Let me come back here. It's a limit of any logarithmic function as it approaches 0 of lim. As it approaches 0 plus is negative infinity. So therefore I can come back here and say that if I give lim of 0 plus 1 here, multiplying 1 over 0, then I'm going to get, this place will be negative infinity plus 1, then this one will be positive infinity. Any number over 0 is infinity. So here it's going to give me negative infinity times positive infinity, which still becomes negative infinity. And that is how we treat limits of transcendental functions. Now let's go to an interesting theorem called the Sandwich Theorem. When you say Sandwich Theorem, all that the theorem is saying is that there are certain functions which we can't find the limit straight away. So we use some kind of comparison. It's saying that if you have three functions, so g of x, you have f of x, and you have h of x, such that the middle one is less than or equal to this, and is less than or equal to this. So here, this is the function, we don't know the limit, but this function we will know the limit, we will know the limit. And what they are saying is, once this is greater than or equal to this and less than this, if the limit of this is equal to the limit of this, then that limit will be the same as the limit of this one. Yes, if the limit of this function is equal to the limit of this function, then it will be also the limit of this function. Let's see this example. Find the limit of sine x over x as x approaches infinity. As x approaches infinity. So let's see. You already know that limit of transcendental functions is undefined. So having this makes this undefined. Hence, you can't find it. So what you are going to do is you choose, you know that sine x has a minimum value of 1, negative 1, and has a maximum value of 1. The next thing is, because this over x, we divide through by x, we divide here by x, then we divide here by x. So from the Sandwich Theorem, I'm going to find the limits here and the limits here, and that will be the limit of this. So here it's going to give me negative 1 over what? Infinity, positive infinity, and that is going to give me 0. Then this side will give me 1 over positive infinity, and that is also 0. Therefore, since the left and the right are giving me zeros, the limit as s approaches s approaches positive infinity of sine x over x is simply 0. That is the Sandwich Theorem. Thank you for joining this class. Kindly subscribe, like, and also share.